How are you? I hope you are doing fine. Today I want us to look at the topic area of quadrilaterals and other polygons. The objective of this topic, by the end of the topic, the learner should be able to find the area of a quadrilateral. That's objective number one. Number two, the learner should be able to find the area of other polygons, that is regular and irregular polygons. So I'll start by looking at quadrilaterals first. A quadrilateral is a four-sided figure. The term quadrilateral is derived from two terms, quadri and lateral. Quadri means four, so and then laterals means sides. So we have four-sided figures. An example of a four-sided figure is a rectangle. So we'll start by looking at a rectangle. The area of a rectangle can be represented by that. We have the length and the width. So here we say area is equals to length times width. So an example, if our rectangle has a length of 7 and a width of 5, then we can say that area equals to 7 times 5, which is 35 square units. Now the next quadrilateral is a square. Now the opposite, all the sides of a square are equal, and also these sides, also the lines of these sides, they meet at 90 degrees. So the area of a square equals to S times S, which is the same as S squared. So if this is S, this is S. An example, you find the area of a square whose side is equal to 10. So area will be equal to 10 squared, which is going to be 100 square units. So I know this you have already done before. So let's move to the next quadrilateral, which is parallelogram. Now the opposite sides of a parallelogram are parallel. These two sides here are parallel. We can say this is A, B, C, and D. So AB, AD, and BC are parallel. At the same time, AB and DC are also parallel, lines that do not meet. So how do we find the area of a parallelogram? So area of a parallelogram, we can name this as B, and this is B, because these two sides, AB and DC, are equal. AD and BD are also equal. So this is equal that, this line equal to this other line there. So we must be able to get the distance between the two parallel lines, that is line AB and DC. So this gives us H. So area of a parallelogram equals to BH, that is B times H. So sometimes you may be given an angle. Let's say you are given an angle 30 degrees here. Then you are given the length. Say the length here is 10 centimeters. And you are told that this is 5 centimeters. Then you find the area of that parallelogram. So this is how you go about it. Area equals to B times H. So in this figure, we have not been able to find H, the height. So we'll use the trigonometrical ratios to find H. So we can say the sine of 30 equals to H over 5. So you remember from sine equals to opposite over hypotenuse. So I can make H the subject. It becomes H equals to 5, the sine of 5, the sine of that, times sine of 30. So this is 5 sine 30. So area will be equal to B, which is 10, times 5 sine 30. If you check from your tables, the sine of that is 0.5. Therefore, it will be 10 times 5 times 0.5, which is going to give us 25 square units or square centimeters. Now, sometimes you may be given a parallelogram that looks like this, where you are given now an obtuse angle. The first one we did had an acute angle. This is now an obtuse angle. This is going to be our height. So first of all, we must be able to get this H by getting 180 minus the obtuse angle, which is 150. So the area will be equal to still B times H. So our H will be, we say, the sine of 180 minus 150 equals to H over 6. This is the same, this is 6 centimeters. The hypotenuse. Therefore, H will be equal to 6 sine of 30. So area equals to 12 times 6 times 0.5. This is going to give us 36 square centimeters. Now we want to look at the next quadrilateral, which is a rhombus. Now a rhombus is a special type of parallelogram because it has some properties. The first property is that all the sides of a rhombus are equal, so they are equal, and then the opposite sides are also parallel. So if this is P, Q, R, and S, PQ is parallel to SR, and PS is parallel to QR. So how do you find the area of a rhombus? Now, in case the first scenario, you may be given the diagonals of that rhombus. And always remember that the diagonals of a rhombus meet at 90 degrees. Therefore, area will be equal to, if you are given the distances of the diagonals, say this is diagonal A and B, then we say area is equals to half AB, where A is a diagonal and B is also the other diagonal. So an example, if you are given a rhombus and then you are told that the diagonal here is 10 and the other one is 8 centimeters. So area will be equal to half times 10 times 8, which of course square centimeters, which will give you 40 square centimeters. That is the first scenario. Now the second scenario, if you are given a rhombus you are given the side, say for example this is 8 centimeters, and then you are given the height, say 3 centimeters. So area will be equal to S squared, which is the side of the rhombus squared, times H. A correction, area, if you are given the side of a rhombus and then you are given the height, the area will be equal to S times H, side times H. So in this case, our area will be equal to 8 times 3, which is 24 square centimeters. Now another scenario, you may be given the angle, the acute angle of that rhombus. Say you have been given 30 degrees. This is P, Q, R, and S. So angle SPQ is 30 degrees. So the area in this case, you will say area is equals to S squared times H. Now our H will be equal to the sine, of course our H if you were to get the H, you'll use 30 degrees and then you say opposite, which is going to be 8. In this case it is going to be 8 the sine of 30. That's why 8 of this side times 8 of this other side, then sine 30 will give you the area of that rhombus. So in this case, it will be 64 times 0.5 centimeters, square centimeters, which is going to be 32 square centimeters. Now let's look at the next quadrilateral, which is a trapezium. A trapezium is a four-sided figure also, with two sides parallel. So we have A, B, C, D. So these two sides are parallel. AB is parallel to DC. So area will be equal to half into A plus B times H. So in this case, this is our A, this is our B, then we have H. So you add, so in case, an example, find the area of a trapezium so we have a trapezium there, 10 centimeters, 12 centimeters, and then we have the height as 6 centimeters. Find the area. So in this case, area will be equal to half into 10 plus 12 times 6. So in this case, we have 66 square centimeters as the answer. So let's look at the area of the other polygons. Now, other polygons may include the pentagon, 5-sided polygon, hexagon, 6-sided polygon, heptagon, 7-sided, octagon, 8-sided, nonagon, decagon, etc., etc. So the first step, if you are given the distance from the center of this hexagon, for instance, say it is 5 centimeters, you can divide this into isosceles triangles so that we have, this is again 5. Now, getting the angle at the center here, you will say 360 over the number of sides, which is in this case is 6. So we'll get 60 degrees here, 60 degrees at this angle. Now, how do we get the area? So we have extracted the triangle with 60 degrees. Then the sides here we have 5 and 5 because these two sides are equal. So getting the area of this small triangle, we can say area equals to 5 times 5, the sine of 60. Now this has given us the area of one triangle. Now because we have 6 of the same triangles on this figure, we are going to multiply by 6. So the total area will be equal to 6 times 5 times 5, the sine of 60. So you calculate, you get the total area of this polygon. So in general, if you are given the distance from the center to the vertex of a regular polygon, area will be equal to half, say this distance here, let me call it D, because this is generally. Then I also have this as theta, and the number of sides, let me call number of sides be n, distance from the center to the vertex be d, then angle of a triangle at the center of the isosceles triangle at the center B, theta degrees. Our area will be equal to half times n times d squared, 306 times 360, sine of 360 degrees over n, where n is the number of sides, d is the distance from the center to the vertex, and then the angle theta is going to be 360 over the number of sides. Thank you and have a nice time.